You think about this, right? Once you put an expression, this part over here is an expression. Okay? Once you put it together on an equal sign and make an equation, things change. Things change dramatically. This is why I'm trying to labor the point on the fact that these things are different to each other. Okay? What's different? Well, do you remember some of the questions that you did yesterday? Okay? They would give you an expression. Okay? An expression might be something like k plus 3. Okay? And then they said, do you remember what we did? What was the heading of yesterday's lesson? Do you remember what it was?
Substitution.
Substitution, exactly right. And we did, we solved and all that kind of thing, right? I can substitute different values of k into here, right? So they said, when k equals, and then they asked you for a number. Like say when k equals 1, okay? What is this expression equal to? And the answer is 4. Good. But just as equally, I could make k something else if I wanted. I could say, how about when k is equal to 20? And you could still work it out. You'd substitute it in, you get 20 plus 3, which is 23. Okay? And I can do this for as many values as I like, right? So in other words, k here, we introduced this idea that it's a pronumerable, but it's variable, right? It can change, and you can put it in. But now have a look at what's happened over here. Now that we've put it in an equation, this expression in an equation, k can't just be anything we like anymore, can it? You can't just put in a number and say, I want that to be k. There's only one value of k that actually makes sense, right? What's the value of k that makes sense? Liam, yeah. 2. It's 2. He's on the ball straight back. Well done. Of course it's 2 because 2 plus 3, that's equal to 5. And there's no other number that you can put into k that'll make it work. Does that make sense? Right? Like if you put in 1 or 20 or 55, all those kinds of things, you won't get an equation anymore because these things won't be equal. Okay? So that number there, in this case, k equals 2. Right? It's very, very important. It's the one value that makes it work. I'm going to write that down. The value of k that makes the equation work. Okay? Now that's very, very informal language. Let me try and make it a little more formal and detailed for you. Instead of saying the value of k that makes the equation work, that little bit there, okay? Another way that you'll hear this said is, it's the value of k, I'll just write the whole thing. The value of k, now this is a bit techy, but stay with it, it means exactly the same thing, that satisfies the equation. What does the word satisfy mean? When do we tend to use it? Yeah, Jasmine.
Makes you happy.
Yeah, it's like, I'm satisfied. This is good. This is nice. I'm pleased with this. Okay, it works, right? I'm content with it. So this is a better way of saying it. This is a more formal way. K equals 2 is the value of k that satisfies this equation. Does that make sense?
Yep.
But that's still a bit of a mouthful, isn't it? It's a long thing to say. So instead, boiling it all down, we turn this into this. An even more succinct, concise way of saying it is, k equals 2, we call it the solution. That's it. It's a weird kind of word, right? But it's kind of short for all of this. K equals 2 is the solution of this equation. Okay? So in other words, the word solution, that's a noun. What's the verb that goes with solution? I think it's solve, isn't it? Solve? If you solve something, you get a solution, okay? So I could say, solve k plus 3 equals 5. Does that make sense? I could say solve it, which means find the value of k that makes it work, that satisfies it. You would say k equals 2. That's the one that makes it work, okay? Can I please get across to you? Remember how I said, expressions and equations, not the same, right? I can't say solve k plus 3. Because this is an expression, right? It doesn't care what k is. K can be anything, right? It's only when you've got an equation that suddenly k is limited. It can only equal certain things. In this case, it can only equal one thing. Okay? Now, let's come back. Excuse me. Pause for a second. I'm going to ask you a question. I don't want you to shout it out. I want you to form an answer in your head in words for the question I'm about to pose to you. It might seem simple, okay? But I want you to see if you can word it for yourself. I gave you this equation, right? And then I asked all of you, now, what's the value k that actually will make it work? What's the solution, okay? And you all came up with this. Now, here's the question. How did you come up with that number? I should think about it in your head. You put it into a sentence. I came up with 2 because... Okay, now I wonder if we can get a couple of different answers. What do you reckon, Lucia? What did you say?
I got the value of 2 because I took 3 of 5.
Okay, so you took away 3 from this number, and that gave you 2. Cool. That works, all right? Did someone have something different, a different way of doing it? Yeah, today. Yeah, say it again. Yeah.
I found 2 by finding the difference of 5 and 3.
Okay.
5.
Yep, good. So the difference between 5 and 3 is 2, and that makes it work. Okay, good. All of these are fine. We arrived at the right answer, didn't we? Someone else might say, well, I just thought about different numbers. Like I tried 1, but 1 doesn't work, does it? You put 1 in, and you're like, 4, sorry, try again, right? So you try another number. So guess and check, okay? You can arrive at the answer very, very quickly because it's an easy equation. It's very, very simple, isn't it? But if I give you a harder one, guess and check, or these methods we looked at, they're not going to be as good. So I need to illustrate this for you.